This conference will now be recorded.
Hello, everybody, and welcome. Again, apologies for the last minute change in topics. If you've been to the Virtual Visitor Center before, you will know that I have been working at the Soo Locks for about 11 years, and my education background is Great Lakes Maritime History actually just Great Lakes Maritime History, and I have a particular love of the freighters and am proud to call myself a boat nerd. And I have slipped in some, not quite random, but I have made sure to include boats in this presentation as well. What I'm going to talk about today is the rock cut in the St. Mary's River, its history, what it's like to navigate through it, and how we maintain it. So my son is an engineering tech, and he has a different perspective than I do, and pointed out that I should also include some kind of general context images of the rock cut, and created this for me. So this is showing the rock cut. Over here is the mainland side, which is on the west, and over here is Niebush Island. And then there are cofferdams that have been and get installed at this end, at the lower end, and up here at the upper end, which is what allows us to do the work that I'll be describing. So anyway, where in the world is the rock cut? I picked this picture because, as most Michiganders are, I'm really thrilled that you can see my state from space. And I can even find my house. It's right about over here. But the St. Mary's River flows past my house and down this way, right between Ontario and the eastern upper peninsula of Michigan. Here's a little close-up view. I've turned it sideways to get it a little more oriented to what we're used to seeing. And down here is Lake Huron, and this is the detour passage area right here. And the transportation traditionally went this way, around the other side of Niebush Island, up this way and up to Sault Ste. Marie. So up here you have Whitefish Bay, and then again Lake Superior. An 1855 drawing shows, of course, the same area. And I will also like to always point out that the St. Mary's River, although we call it a river, is actually a strait. It's a series of connected lakes. So we have Mud Lake down here, we have Hay Lake over here, Lake George over here, and of course up here, Whitefish Bay. Now the area we're going to talk about, or I'm going to talk about, is right here, this Wes Niebush Rapids. And again, here's that route that they traditionally use on the back side, and you can see there's quite a few tight turns there and through the middle, Niebush Rapids. Getting ahead of myself there, sorry. So anyway, that passage on the other side of Niebush Island, extremely important. It hosted two-way traffic, or carried two-way traffic, and the U.S. Army Corps of Engineers, from pretty much the very beginning, was constantly busy maintaining the channels through that area. This photo from October 1889 shows one of these crews that were assigned to this task. They would be taking soundings and then overseeing dredging, which was usually done by contractors. Here's one of these dredge fleets actually working in that middle Niebush channel to keep it navigable for the vessels going by. Now, this is a drawing, or a chart, I should say, from 1895. So again, we're only taking traffic up this way through the middle Niebush Rapids and on the backside of Niebush Island. And then this area right here is the West Niebush Rapids, and that was the barrier to navigation. If you have a high enough resolution on your screen, you might be able to see right in here, the water in this West Niebush Rapids is only 3 to 4 feet deep. You could, if you were tall enough, could just walk right across here. And then if you can see the descriptions of the material here, it's rock. So not a way to transport freight vessels. So they had plans for a separate channel that they started working on in 1897 to have two-way traffic around Niebush Island. And this is a huge undertaking, and they got started in 1902. This is a picture of one of the cofferdams that were used at each end to block off the canal area for excavation. So they have pumps going right here, and you can see the water kicking out of those pipes over there to keep it dry. And here's a drawing again, thanks to my brilliant son, showing the highlighted bit is the dry work area that's created when they put in these cofferdams at the upper and lower end. And then they had a dry work area to work in. And the work that they were doing was a lot of drilling. This is one of the many pneumatic drill rigs that they used to drill the holes to set charges, which then, of course, would be used to blast the rock. The topography in this part of the river is limestone. So we have a limestone bedrock pretty close to the surface. In total, they blasted away 1.7 million cubic yards of limestone to carve out the canal. This is one of the steam shovels that was used to start moving around and removing that material. One of the neat things in this early construction from 1902 through 1908 were these skips that they used to haul the stone out. So they have these great big towers that they assembled with these almost like a tram running back and forth, and they could load up these skips, and then they would haul the rock in and out of the, or I should say out of the canal area. One of my things I really like about this photo in particular, if you see right here is a crew of guys, they're using those pneumatic drills, and they're starting to remove that first layer of material, or nearly first layer of material here at one end that they're working from. And if you notice, it's kind of sloping. You can see almost like when they built the locks, they kind of start at one end and they start steadily working their way to the end and doing the finishing details as they go. The tops of the canal walls were topped with ashlar masonry stone. So some of the stone that they were removing was dressed into square and rectangular shapes. Some of these blocks weighed up to 2,000, or I'm sorry, not 2,000, that'd be ridiculous, weighed 2 tons per block. And then those were all set atop the wall to form the upper portion of that. This is a really nice panoramic view of this, and you can see the width of this canal, which is 300 feet, and it runs a mile long. This is 1907, pretty close to it being completed. And these walls, you can see this ashlar masonry walls are actually quite attractive. I mean, they're really kind of stunning and beautiful. This is 1907 again, and we're going to keep talking about these walls. This is another one of my favorite pictures. It's showing man, sorry, technical problem there. My TV shut off. Let me reset here.
Okay.
Just be a few seconds while I get this reconfigured. I was afraid this was going to happen. I'm working with different equipment.
Give me a second, I'll swap it. Michelle?
There we go, I'm back online.
You can do a hard swap there quickly.
Let me get things repositioned. My apologies, people.
Just give me 1 second. Should shut down now.
Okay, my husband assures me he has fixed the problem and we will get going again. All right. So again, we've got these people posed in the bottom of the rock cut, which is one of my favorite photos from the rock cut collections. This is 1907, and I'll point out here, this is actually channeled rock. So basically they had to cut the bedrock straight down. And I always like to point out, this is almost like a swimming pool. You see there's like a 90-degree angle right here from the bottom of the canal to those walls going straight up. This is a little family that apparently went there for an outing, which I think is pretty cool. I would be ecstatic to be able to go get my picture in the bottom of the rock cut. I'm not sure my family would be interested in joining me. So the canal opened in 1908, and by 1910 they have updated the charts, and we're now seeing that two-way traffic. So upbound traffic goes through this shallower canal on the other side of Niebush Island and through the middle Niebush Rapids, and then downbound loaded traffic is coming through here and going through that rock cut, cutting down on congestion and all sorts of problems with collisions and everything else that was happening up here. This rock cut, as I mentioned, is a mile long. It is 20 feet deep and 300 feet wide. And it was well used. It eliminated a lot of the problems and delays that they had from collisions and having to operate at slow speeds. But the masonry did require pretty much constant repair. The freezing and thawing cycles kind of was frost jacking or frost wedging and made the walls unstable. By the 1920s, also, the boats were getting bigger. Here you see one of the 600-foot-long boats. This is the Richard V. Lindbergh, which launched in 1923 and sailed until 1988. And boats are wanting to load deeper, carry more cargo per load. The boats are getting bigger. And the rock cut is kind of the choke point for those deeper drafts. Because of the project depth is only 20 feet, that is limiting how deeply they can load. So in 1930s, they decide to deepen that channel. There's a new project depth of 25 feet through the St. Mary's River. And so they put those cofferdams back in place and pump out the workspace here. It's almost to the bottom. They're still doing the pumping. And I want to point out this vessel over here, the Indiana. This was a passenger package freighter or steamer. And this, during the work on the rock cut, it actually served as a floating barracks for the contractors and a workers' hotel. And it also served as the powerhouse. So they were using its boilers to generate power to run the equipment. When the project was done here in Sault Ste. Marie, they actually sold the Indiana to another contractor that was doing work on the Livingston Channel further down the lakes. The Indiana, for the boat nerds, it launched in 1890, and this picture was taken in 1931, and it was scrapped pretty soon after being used for the Livingston Channel. Here you can see this is the birthing spot where that Indiana was, and then this, of course, is where those upper cofferdams are to create the dry workspace for those 1930s construction. And again, they're doing pretty much the same thing they did in 1902, although they have some probably snazzier tools. Although if you get a look at these guys' faces, that looks like a hard, miserable day of work. They had to drill a lot of holes and do a lot of blasting to get it that 4 or 5 more feet of depth. They did have some more advanced equipment like this drill rig. And here you can see them using a drill rig to do that channeling right along those I'm used to talking about locks along those canal walls. So they've got to keep that straight angle because they want to keep that 300 feet. So they've got to drill straight down there. They didn't have the overhead skips this time, but they did have plenty of great big trucks. So you've got a steam shovel here loading the rock and debris into a 5-ton dump truck, which is then driving it on a ramp off to a disposal area. And I mentioned the Ashlar Walls, right? I said we'd be talking about those again. Well, they are a problem, and they have been a problem from the beginning. This picture is from 1930s, and you can see that they are pretty seriously failing. So in the 1930s, while they were doing that work, they did what they could to stabilize them, and the channel was then back in business. Here we see the Arthur B. Herman. This picture's from, I think, 1960 or so. And this boat was launched in 1959, sailed until 86. It started out a 730-foot long boat and was lengthened to 807. Now, again, if you followed the Soo Locks history programs, you will remember that between 1855 when the locks opened and 1972 when the Stuart J. Court was launched, boats kept getting bigger and bigger and bigger, and there was always pressure to expand our infrastructure to fit them. And by the late 1950s, 25 feet is starting to feel pretty shallow for all these new boats coming out. And so in 1960, they decide they're going to lower it another 3.5 feet, 3.5 feet, to a new project depth of 28.5 feet, which is still the project depth through that part of the river today. And crews, again, were busy replacing that and repairing that masonry wall because of its instability and falling into the canal. The channel's not been deepened since, and it does still remain critical to navigation. This photo is from 1971, and what I'm curious to see, does anybody recognize this boat? Who knows what boat this is? It's kind of backlit. It's one of the famous ones. And I will also confess that this photo and most of the other photos of boats coming through the rock cut were given to me by a friend of mine who many of us like to consider the king of the boat nerds. And yes, you're exactly right. This is the Edmund Fitzgerald, photographed in 1971, heading down the rock cut. Now, the channel's not been deepened since then, but it does remain critical to navigation. And now you know how we built it, and would now tell you a little bit more about what it's like to go through it. The channel, as I mentioned, is 300 feet wide. And once you're in, it's like dead arrow straight, so it's really easy to navigate. It's the getting into it that can be really tricky. Right here, if you're coming downbound, you're going to follow, oops, what did I do? I clicked the slide, sorry. You're going to come downbound through this route. You're going to have to start going right. And then when you get into here, it starts to get a little tight, and you're going to have to make a pretty hard left. That's a 56-degree turn to get yourself lined up and into the rock cut. And I will point out that these boats, as you probably realize, do not have four-wheel drive or emergency brakes. So they usually start to slow down long before they get near those turns. And if something goes wrong, it can go wrong and get serious really quickly. If anybody's familiar with the area around the Niebush Island Ferry, you might appreciate that this is really a really beautiful shot. It's very well framed with rocks in the foreground and the trees and the island over here. But you should never, at the Niebush Island Ferry, see a boat like this sideways. At the Niebush Island Ferry, at this point, you should be seeing that boat bow straight on, heading straight towards you. And while it looks like there's plenty of water around this boat, this is the Pollard Tregurtha in 2012, it looks like there's a lot of water, so it's like, well, why don't you just back up and move? The channel is actually much narrower than the water that you see here. There is some room for turning, but it's a narrow channel, and this boat is actually hard aground on both ends of the boat, the bow and the stern. So right here, you see there's like how big that water area is, but this is the width of that channel that's dredged. I mean, it's a little wider to allow for that turn, but if you miss something on that turn, things get serious real quick. To prepare for this program, I was talking to a friend of mine who is a wheelsman on one of the 1,000-footers, and I was just trying to ask him about, well, like, what's it, how do you get ready and how slow do you go? And he's like, I'm just at the wheel. I'm mostly watching. And he says, yeah, I know we slow down. I don't know how much, but he said, and I was like, well, where do you make your turn and which lights? And it was kind of interesting because he was describing, and I asked also, what's the difference between night and day? And he said, there's none, because he goes entirely by the lights and the markers. And whether it's daytime or nighttime, he's going by those markers. And it was kind of fascinating as he was describing. He doesn't have the numbers in his head, but he's like, oh yeah, when I see the green buoy, that's here, and I need to do this, and when I see the red over here, I'm going to do that. So here he's looking at this green one. This is where he's got to start making that 56-degree turn. This is from the back end of a 1,000-footer. And then he started talking about, well, then I start to see the right, or the red light over to this side, and then the green light starts to line up with this thing on the shoreline, and then gets straightened up. So they're, oh, and I'm dead on. I can see this right in front of me. And then away he goes. Once they're in the cut, that mile goes really smoothly. As I mentioned, it's a dead arrow straight, but it can be a challenge in the winter, like all navigation on the Great Lakes. So here you see a shot he shot over the side of the boat, and it's hard to tell where the shore starts and the canal begins because there's so much ice in the canal as well. And then all of this churned up ice can be really bad news because it's not necessarily just on the surface. There's a shot from the other side. And then once he's out of the channel, there's more tricky navigation to come, because as you see here, they're coming out of the rock cut, and then they've got to start going right. It's a pretty gradual right, no big deal. But then when they get over here, they've got to make a pretty hard left to go between this end of the island and Moon Island right here. And away they go. I have a short 30-second time lapse that I hope will run smoothly.
Hey, Michelle, just really quick before you do that, we just had a question about the ship that you were talking about before that didn't turn in time. What happened?
I'm gonna get to that, but I will tell you, hopefully you'll consider it good news. It's not still there. It did eventually get freed up, and I'm going to talk about that a little bit later in the program. So I hope you'll hang in there for it. So I'm going to try to get this video to play for you. Oops, something went wrong again. Oh, here we go. Wrong one. Here we go. I've got too many things running. Why isn't it playing? Oh, there's my play button. So here he's approaching the cut, and he's watching for that buoy, making the turn. He's shooting through the rock cut. And then now as they're leaving, they're starting to make that right turn, get around the island. And if you watch up ahead, you'll see Moon Island. And that hard left turn to avoid all that shallow water on the other side. And that video footage came from Mike Schrag, who was very kind to share it with me to use in our visitor center. You can see the whole video in the visitor center theater. It actually starts from leaving the Soo Locks, going all the way out to the Detour Light. And you can also Google that or look for it on YouTube. If you just type in Paul R. Tregurtha time lapse, you should get that video to load for you. So, as I mentioned, we have not deepened the rock cut. The project depth is still 28.5 feet. But since 1968, its maintenance is pretty much nonstop, as most of the work in the channels around this island have been. Boats, as they go through, they're washing in rocks with their propellers. This is that picture of the Court. And I like to always point out, this is also the Court, and that's the size of its propellers. The Court has 14,000 horsepower in its engines. So if you imagine a propeller that size with 14,000 horsepower behind it, that's going to churn up a lot of rocks and a lot of mess. And the Court is not even the most powerful boat on the Great Lakes. So we have to regularly check the rock cut to make sure that there are no obstructions to navigation. They're what we would call strikes, things that project above the height of the project depth that would cause a problem for navigation. And we do this by taking soundings. This is a sweep raft, which is about 100 feet wide. It would go through the water with cables lowered. These cables are lowered to the project depth, and then there's a steel bar that connects them. So if those cables and that bar hit an obstruction underwater, it's going to cause some vibration, and the men monitoring it on the deck are able to make a note. They stop the raft. Another person takes a sextant at that time and would get a precise bearing on where that location was. And then they would start raising that cable up a little at a time to figure out how big that obstruction is, how high it projects from the water. And then they would start moving that raft again to figure out the dimensions of it. This rig took 7 men to operate, and it would take 4 to 5 days to do a complete survey of the rock cut. And I was kind of surprised to find out that this piece of equipment was used at the Soo until 1992. In a little bit later, it was replaced or began to be replaced by the Joseph M. Bray, which you see right here. And this is a self-propelled survey vessel. And this one is using sonar. It has 32 single beam transducers, which you can see mounted to the hull of the barge right here. So each of those is going to send down basically a ping of sound and record how long it takes for that sound to come back. Here's a little diagram kind of showing how it's sweeping the bottom of the channel to measure the depths of the water below. This one had a crew of 3 people, and it could survey the rock cut in a single day. We used this one from 1986 until about 2000. And this is the one we use now. Absolutely fabulous little boat. It's 26 feet long. It's not huge. We use this one. It has a multi-beam sonar, and it's set to scan for anything that projects about an inch above the project depth. So if you're at 28.5, this sonar is not gonna, we're not gonna ping that. If you're at 29 and a half, I've got my math wrong. If you're at, you're an inch or two above that 28.5 feet deep, this is gonna catch that and they're gonna make a note of it. I don't have all the technicals on this piece of equipment because I'm afraid I'm not a gearhead, but if you are interested, shoot me an email and I can get the question in front of somebody who is an expert. Basically, this is how this one works. So we're using the multi-beam on our boat up here, and it's shooting a huge arc of sound, and it's taking 3D imagery of what it goes over. Now, in the case of, I'm pretty sure, I wouldn't bet my paycheck on it, but I'm pretty sure this is that area in the rock cut, ahead of the rock cut where the Polar Tregurtha ended up across the canal. And all the red that you see are strikes. So basically that's something that is now above the project depth that has to be removed so that other vessels can safely navigate. The Polar was stuck there a couple days, and then it took us a couple days to get it cleared up. So traffic was backed up for, as I recall, maybe close to 4 or 5 days. I want to just show off a little bit about what that sonar can do because the little red dots are not all that impressive. This is the Samuel G. Mather. It's in 180 feet of water in Whitefish Bay. And this is the image that sonar was able to get when it was driven over this wreck site. This boat operates with only 2 people, a pilot and a survey tech, and including getting to the rock cut, they can survey the entire rock cut in 3 hours. So if they get a call in Sault Ste. Marie that there's been a strike, they can be completely done with it in less than half a day of work. Now, I mentioned that they do regular soundings of the channel, but they also survey if there is a strike. A strike is what is anything that a boat would hit in the waterway. Could be rocks, could be a debris pile, a car, whatever. And if a ship hits a strike, quite often they'll feel some vibration and they'll report it to the Coast Guard or the lockmaster. And then they contact our chief of river operations. And then this survey crew is dispatched day or night, rain or shine, sleet or snow. Even in the winter, as long as it's not completely frozen, even if 3 in the morning, the boofy crew will be out surveying it because, of course, the river is, or not the river, but the rock cut is shut down until it's cleared. In December 1958, the Howard L. Shaw was unable to make it through the rock cut. I mentioned ice can be a real big challenge. This boat was the last boat in a convoy. I think it was the 12th boat. And of course, what ended up happening, you'd think being last, you'd have a nice clear path, but actually you don't. What ends up happening is all the boats ahead of it churned up all this ice and brought it into the canal here. And what this boat is actually kind of suspended in a big mess of ice and sleet and slush, and there's very little moving water for it to really get any momentum with. According to the news reports from this, they had estimated that it was sitting in ice that was churned up 24 feet thick within the canal there. It took 2 tugs and the U.S. Coast Guard Mesquite to get it free finally. Now, when that happens with a little boat, it makes a big mess and it slows down traffic. When it happens with a bigger boat, like a footer, it can make a huge mess. And you've got heavy duty horsepower in that boat. This boat's probably got close to 19,000 horsepower. It's got those gigantic propellers that you saw in the earlier photo. And then, of course, the Mackinac is not exactly a lightweight. None of those ice-breaking tugs are little tiny power boats. And what happens, of course, now this canal is filled with slush. Their theory was that they were actually sitting on top of ice that had frozen to the bottom of the lock. It took, the Mackinac tried for a couple days. This boat was there for 3 days before they could get it free. They eventually got it free using 4 commercial tugs, like even great big ones like the Joseph H. Thompson. And what ends up happening, of course, you've got a lot of horsepower in the Got. You've got a lot of horsepower in these Icebreakers. Well, they're going to make a mess on the bottom of the river. And this is some of the survey data that we took as soon as they got the boat cleared and we were able to get the buoy in there. Luckily, this happened at the end of the season because I'm not sure we could have gotten a crane barge in there to remove those at that time of year. Here's a little bit closer up. Hopefully you can see the kind of the 3D. So you see these pits probably from the propeller wash. And then, of course, all that debris that gets excavated by the propellers ends up in little piles all around. So that all had to be cleared before the canal could be opened up again. Just another reference of where it is within the canal. And then, of course, we have a part 2. The buoy, of course, can find the strikes. It can't remove them. This is the vessel that we use to remove the strikes. The Nicolet is self-propelled. And this boat literally picks up rocks. It has many, many missions, but rock picking up is one of its biggest ones. And this isn't in the rock cut, but it's still a good illustration. This is from the east approach to the locks. And once the buoy finds a strike, they can send those coordinates to the Nicolet. The Nicolet can go right to that spot. The Nicolet has its own sonar to kind of see the rock right there for themselves. And then they drop their bucket and pick it up. Once they're done removing a strike, they then can use their sonar to kind of sweep the area and make sure that in removing that rock, they haven't disturbed something else and created another strike. This boat takes a 4-person crew as a master, a pilot, a crane operator, and a deck operator. And you might see this one around the Soo Locks too if you visit in the Soo, because it does do other things as well. So I mentioned the project depth hasn't changed in the river and in the rock cut since the 1960s. And we have not dewatered the rock cut since then, but the Ashlar masonry walls, they're still a huge problem. And even after rebuilding them and multiple efforts to stabilize them, one of the things we tried to do was these concrete blocks. We have these, they just made concrete blocks and tried to pin them into place, hoping that would stabilize it. They also did some experiments with grout and other materials, and none of it was really working. By 2014, about 50% of the walls had failed and fallen into the river, into the canal there. And so in around 2012, they started a project to start pulling off those Ashlar masonry walls and create a sloped bank. So here you can see they're using kind of surgical precision to like pick up these huge individual pieces. And then they're using a little bit more rough measures to create that slope bank. So there, here you see where that original wall is, and that's where the 300 feet starts for measuring that canal. They're kind of building back that slope a little distance from the canal. So if things do slip a little, it's not like a 2-ton rock falling into the canal. And they load that all up into dump trucks, and then it went over to the disposal area. Now, an interesting thing about the disposal area, you can see all this here. These are all spoils and materials excavated from all the previous work that's been done there. The Corps was able to save millions of dollars because we used those excavated materials, that's more than 2 million cubic yards of material, to stabilize those banks. And then we used them also to create an access road. So not only did we slope the bank back and stabilize the wall, we've created an access road so that if we do need to do work down there, or even for inspections, rather than having to run everything down on barges and possibly work from barges, we have an opportunity to just drive our heavy equipment right there. So I've shared some of the history, and I've talked about what it's like to navigate through and how we maintain the rock cut. But one of the things I want to make sure I emphasize is how critical the rock cut is. It may not be quite as much of a choke point as the Soo Locks are, but when there's a problem in the rock cut, it can pretty quickly spread to the entire Great Lakes. You asked about the Paul Archagurtha when she was wedged over here in front of the rock cut. Traffic slowed down, stopped. There were a few boats that could go down the other side of Niebush because they were small enough and a light enough draft, but most of them were ended up parked. So they're sitting for days and days and days. Well, if they're sitting for days, that means that the people in the mills and the power plants that are waiting for those materials they're bringing are, of course, going without them. It also means that things are getting backed up at the docks. They don't all have unlimited storage capacity for the bulk cargoes, and now all of a sudden nobody can come and load. So it spirals out pretty quick. That incident with the Spear in 2004, when it was trapped in the rock cut, that also shut down traffic for almost a week. It was the end of the season, so they knew the rock cut was not going to open again. So the big boats didn't really have the option to sit it out, because that was like around January, I think 15th or so, when that actually happened. And what they ended up having to do, there were boats coming up empty because they were going to their seasonal layup, and they ended up unloading the big boats into the small boats right in the river, so that the big boats could at least get light enough to get down the other side of Niebush. So it's a little 1 mile stretch of river, but it ended up slowing everything down, costs, I don't even know how much money in the delays. And then, of course, it backed up work going on everywhere else. And now we've got the rock cut in our rear view, and I will turn it over to Sarah, and you can have a few minutes to ask some questions, and I will stand by.
I'm coming. All right. Well, thank you very much, Michelle. That was really interesting. Before we get to questions, I just want to provide a little bit of an update on our respective visitor centers. The visitor center in Duluth has been closed since March, and we have been making efforts to make some of our information virtual and available to people without having to come into the visitor center. So we are still doing vessel arrival and departure announcements through the end of the shipping season. We have a cell phone tour that's available outdoors. We do have a virtual online tour of the museum, and we are in the office answering questions by phone. And a new update for our gift shop. Our association's gift shop has an online presence now, an online store. So they are located at marinemuseumgifts.com. And as far as the Soo Locks Visitor Center in Sault Ste. Marie, Michigan, their park is open from 9 to 6 main gate, and their visitor center closed in October for the season. And both of our visitor centers will reopen once we can comply with state and local guidance and once the local health conditions permit. And then I'm gonna leave this other slide up here while we answer questions. This slide has all of our contact information. It's got our websites, our Facebook pages. The YouTube channel is where the recorded version of this program will live. And you may also see announcements about that posted on some of the Facebook pages as well. The vessel schedule hotline in the Twin Ports is listed, as well as our vessel schedule website. And then we also do have an email list if you're interested in joining our email list and learning more about upcoming programs. You can send a message to hellolsmbc@gmail.com. And then there's also a survey at the very bottom that will help us improve our programs and give us some ideas for new programs. If you want to take a few minutes just to take that survey, that's very much appreciated. And then coming up on December 17th, again, Frank Bowles, who's an author, will be talking to us about his time on.
Hey, Sarah.
Yeah.
Let me tell you a little bit about Frank, because I realized I did not send you a very good description. Frank Bowles is the director of the Clark Historical Library at Central Michigan University, and top-notch scholar, funny guy, and after years of knowing him, didn't realize he was also a boat nerd. But he has written this book, Sailing into History, which is excellent, highly recommend it. If you don't know a lot, it's a really good introduction. If you do know a lot, you will probably find some new ways to think about things that you knew for a long time, which was my experience with this book. And it's going to be a great program.
All right, thank you for that. I'm going to put the link to the survey in the chat so you can access it more easily. And then we can get to the questions. We have a couple of questions piling up here. Going back a little bit, how do the huge freighters and salties know that they struck something?
Usually they can kind of feel a vibration, because what will happen is, of course, these boats, I didn't mention in the program, quite often they may be only a foot above the bottom of the rock cut, because of course they want to load as deeply as possible, because the more you can haul in a single load, the more money you make and the more efficient your operation is. So sometimes, because those water levels can fluctuate, they may find they're only a foot, so maybe even less, above the bottom of the river. So if they hit an obstruction, it will kind of like roll along the hull and you'll hear it. So there'll be like a rumbling and a little bit of vibration that's not expected. And then, of course, they usually immediately notify the Coast Guard and or the chief lockmaster.
Okay. Where's the heavy equipment, the dump trucks from? Do you use any equipment from the Dolomite Quarry in Cedarville, or does the Corps of Engineers have their own equipment set aside somewhere in the Soo?
We have a lot of equipment. I really could not tell you about the equipment that we saw in those photos, but I will confess, as a non-gearhead, we have a lot of big, amazing machines at the Soo. We have a lot of storage yards. Our facility at the Soo Locks it's a lot bigger than what you see at the locks. We have cold storage yards, and we have a whole maintenance facility with a huge parking area where all that gear is. But we do also rent equipment. And I don't think we get it from the quarry, because of course we have to use the government acquisition policies and procedures. And so we have to go through all our chains to be able to rent heavy equipment like that. If you're interested, I will put my email in the chat, and you can send me that question again and I can try to find out from somebody.
Another question here. Besides being used for the wall, where did they dispose of all the dredgings and limestone rock?
I didn't hear the first part of your question. Could you repeat it?
Besides being used for the walls and access roads, where did they dispose of all the dredgings and limestone rock?
If you go to Barbaro or Niebush Island, you will see it. There are huge rock piles. That slide that I showed where I talked about we used all the excavated material to stabilize the walls, all those piles, the entire rock cut is lined with rock piles like that. And that's from all those materials. They basically just hauled them out and dumped them.
Okay. If the rock cut had some sort of severe failure that might make it inaccessible for a week or more, would ships be rerouted to the East Channel, even though it might be a bit more dangerous?
They sure would. And that's what they have done in the past with any boat that's loaded light enough to go through. Of course, you're going to have, there are speed limits in the river, and you're going to be having some pretty serious speed limits in the river if we're having to do two-way traffic. Before the rock cut opened, there were no boats more than about 500 feet long, if even that. So now we've got 1,000-foot vessels. So I'm not sure. I should have found out in advance. It was probably one-way traffic while they were doing that. So they probably would have been moving them in convoys. So you'd bring up a bunch of them upbound, and then you'd bring back another downbound. So you would have one-way traffic, but it would be staggered. That's my theory.
Okay. Where do the pilots get on and off upbound and downbound for the Salties who don't know how to navigate the St. Mary's River?
I think they get on at Detour, and then there's usually or often a pilot change in Whitefish Bay, or sometimes I've seen them do a pilot change just above the locks in the Upper Harbor. And of course, that's only for Salties. All of the Great Lakes captains, they don't need pilots. They're all licensed to operate on the river.
Okay. Is there a good written history of the rock cut?
I am not sure. That is certainly a good question to ask. I think there is a Niebush Island Historical Society, and that might be a good place to start to check into that.
Okay, let's follow up.
If anybody wants to write one, I have lots of pictures.
Does traffic go both upbound and downbound in the cut?
Nope. It is one-way traffic on both sides of Niebush Island.
Okay.
I presume maybe if something terrible happened on the east side of the island, then they might do kind of that staggered up and down, but not at the same time. Because if you think about it, 1,000-foot long boat is 105 feet wide, and then that channel is only 300 feet wide. You theoretically could fit 2,000-footers side by side in that canal, but you're not going to have very much wiggle room. And once you start putting them in motion and you have water, the forces of water moving in different directions in that contained space, it would be catastrophic, I think. Not end well.
Mm-hmm. Is there a list of accidents/incidents in the rock cut?
Not that I have compiled or am aware of. I think that might be something that Soo Control, the Coast Guard, would probably monitor, because we aren't involved necessarily in like the investigation and documenting when there's an accident. We're all cleanup. That's what the Corps of Engineers is doing. So I'm sure in our records, we probably have all kinds of stuff about strike removals, but that wouldn't necessarily correspond with any kind of mishap with a boat in the cut.
Okay. And are currents and squat issues?
I know what that means.
About currents or anything in the rock cut?
That's something that is monitored when boats call in. If you're a boat nerd and you listen on your home radio, you'll hear them call the tower, and as they're getting dispatched, the lockmaster will start telling them a whole bunch of numbers, +1, +2, -1, -2, and all these different locations. The rock cut is one of those that they do report. They will tell what the depth above or below datum is in the rock cut, because we've also had times where, because the water isn't always set. wind and air pressure can change it and make it kind of fluctuate. And so there have been times when boats are loaded and they're good because, for the last 3 weeks, the rock cut has been at, +1. And then they get here and something has changed and now the rock cut is at like -6. So then they have to sit and wait until there's enough water to go through the rock cut. And then at that same time, when they're getting dispatched, they're also often getting the flows. So how much water is flowing through the river, and that can help them kind of anticipate what currents are going to be.
Okay.
Yeah, it could be pretty bad if you saw that time lapse. You get shot out of there like in a water slide. That might end badly.
Yeah, I can imagine. Someone was asking about the channel depths in both sides. Is the rock cut the same depth as the east channel?
No, the east channel is actually a couple feet shallower. So that's why that one's used for upbound, because most of the boats coming up are empty. The majority of boats come up empty, or else they're smaller boats who don't have as deep of a draft. Which is why when the spear got stuck in the ice, they actually had to unload these big boats into other boats so that they could get their draft shallow enough to get through.
Okay. Is vessel traffic in the rock cut controlled by the Corps, or is Sioux control Coast Guard?
All traffic in the river, once they hit Whitefish Point and once they hit Detour, is controlled by the Coast Guard. The only part that we kind of control is the dispatching at the locks. So if some people have thought Sioux control when they hear it on the radio, this is Sioux control, that's actually the Coast Guard. That's at the Sector Sioux, just down the street from us. And the only thing we are like bosses of in control is the dispatching at the locks. So that would be a provenance of the Coast Guard to deal with people violating speed limits or other things in the rock cut.
Okay. Has there ever been any talk of making it wide enough for two-way traffic?
No. Not that I have heard. And then we have pretty wide canals at the Soo Locks, and we don't let two-way traffic be in motion between those piers. And when you look at the sheer volume of material they had to move to make it the first time, you would probably have to almost double the size of the canal for it to be safe for two-way traffic. I don't see us undertaking something like that when we're able to do two-way traffic around the island now.
Yeah, it sounds like it would be a lot of work.
Yeah, and getting things through the EPA and all those other agencies was probably very different in 1902 when that project started. I'm not even sure if our Corps of Engineers regulators would sign off on such a thing now.
Okay, question. I'm not sure if you'll know this, but how many icebreakers does the U.S. Coast Guard have, and what percentage of them are in the Great Lakes?
Oh my gosh, I have no idea how many they have, but I think we have about 7 or 8 on the Great Lakes. I think there's maybe 6 Bay class breakers. Those are the 140s, the black ones with the red stripes. A lot of those also work as buoy tenders, and then of course we have the Mackinac. There are also though Canadian icebreakers on the Great Lakes, which we work very closely with. And one of the cute stories, the survey guy who yesterday was very patient explaining everything to me, brilliant man and very patient explaining to somebody who doesn't understand what he's talking about. He was telling me about one of his most exciting or fun things he did on the Boofy. This was I think 2017. It wasn't that long ago. There was there'd been a strike or something in the rock cut, and they had to go get there, but there was too much ice. They couldn't launch the Boofy. The Boofy goes on a trailer, but there was nowhere they could launch it, and they couldn't get there from the Sioux because of the conditions, and it's just a 26-foot little boat. So what they ended up doing is they loaded the Boofy on the Samuel Risley, which is a Canadian icebreaker. So they loaded the Boofy on there, and they took our crew on board and said they spent the whole day on the Risley getting down to the cut. And when they got to there, they took the buoy and launched in the water and brought them back. So we have pretty good relations with the Canadian Coast Guard too.
Okay. With the Great Lakes being at record highs, what is the actual depth of the rock cut now, or at least this past summer?
You know what? I wish I could tell you. It is high because the datum depth that they talk about all the time, and I'm going to do a really bad job as a historian trying to explain something that's geography and geology and science. The datum is an aggregate kind of average number. It's based on like a 5-year span because water does fluctuate. And they figure, okay, right here is the datum depth. This is where it's 28.5 feet. And so that +1 +2 is the lockmaster saying how much above or below datum we are. So if you listen to the lockmaster and if he says, you know, we're at +1 or +2, he's telling you how much above datum that water is. And I'm afraid I can't tell you today. If you can shoot me an email, find out.
Okay. What is the speed limit for ships in the rock cut?
I am not sure a speed limit in the rock cut. Oh, somebody just sent it to me. The water is +45 inches today at the rock cut per NOAA. So take 28.5 and add 4 feet. So it's pretty deep. Pretty deep. So I forgot what I was answering.
Speed limit.
Speed limit. I am not sure in the rock cut. I imagine it's kind of a whatever's prudent and nobody wants to wreck their boat. In the rest of the river, it's 10 miles an hour. And so they're already slowing down when they start to approach the rock cut. But again, I can ask somebody and try to find out if you want to shoot me an email. I'll put my email in that chat because I keep telling everybody and I haven't given my email out.
Okay. So another question about who owns Niebush Island. Is it private homeowners or part or all owned by the state? Someone in the chat answered it was private homeowners, but if you have anything to add to that.
I don't. I think it is all private landowners, but I will say and there's a right-of-way that comes into play with the Corps of Engineers and the federal government for navigable waterways. So while it is all private property, there's a right-of-way at a certain distance from that canal that the Corps of Engineers kind of controls. And because we have to maintain that piece of navigation and we can't give up that access.
Mm-hmm. Okay. With the current amount of traffic through the rock cut, how does this compare to the maximum capacity?
I'm not sure what you mean by maximum capacity. I mean, it's basically probably pretty similar to the capacity at the locks. And what's going to happen is, I mean, we don't have like a whole, it's not like a biker gang of boats all side by side racing in. Once they come in at detour, they end up in a line. And there's one after another. And almost never does a boat pass another boat once they get into the system. And so, I mean, it can be then in that case almost endless because they're all going one at a time anyway. Of course, you do want a safe distance in case something goes wrong, like in 2012.
Yeah. Okay, someone chimed in with a potential answer to the speed limit question. I believe it is 8 miles an hour based on photos of the old Coast Guard observation station.
Cool.
Okay. What went wrong when the trigger grounded?
I have heard lots of different theories. I don't know what caused the accident, but the what actually happened, as I understand it, as it came into that turn, it missed the turn, and it drove its bow into the bank, and then the momentum of the engine going caused its stern to kick out and hit the other bank. What caused that to happen, I do not remember, and I'm not comfortable to try to even speculate. There were lots of investigations, and I think it was almost maybe 2 or 3 days before they even got her off and out of the way.
Okay. Who has the right of way in the rock cut? If there are sailboats or pleasure boats versus Great Lakes freighters, who goes first?
You know, I think that the basic rules of the road are sailboats usually have right of way, but I think it's a foolish sailor who's going to insist on it with a 1,000-foot boat loaded up with 70, 1,000 tons of iron ore to insist on that. But in any case, though, there is room for a pleasure boat and a freighter. So you've got 300 feet, and if you're in a small pleasure boat, there's room for you both in there. But be smart around the freighters. They don't have brakes. They don't have four-wheel drive.
Yep. Okay. Someone just commented, draft restricted vessels have right of way over sailboats within any defined channel.
Well, there we go.
Okay. Well, thank you everyone for all the questions and all chiming in for the answers. We're just going to wait a couple more minutes, see if we get any last minute questions. Someone just asked, is there a live cam somewhere in or near the rock cut? I've seen some crazy things just south of Mackinac Island. Are there any live cams in the St. Mary's River?
There are live cams all throughout the river, but I don't think they're public. I know that Sioux Control has cameras all over the river, and we have access to them. Our lockmasters do. I've told a funny story because sometimes the boats are coming from different directions. They both want to get the lock first. They don't want to wait because it costs them money to wait. And there have been times where a captain has fibbed about where he is. And then our lockmaster is able to go to his camera deck. If it's not looking right on his AIS screen, he can go to his camera deck and pull up that location. And we've actually had one where a captain called in to get dispatched, and our lockmaster got back on the radio and says, you might want to check your location there, Captain. I don't see you at Big Point. I'm looking at the camera and I'm not seeing any boats. And then, of course, everybody on the whole river heard that this guy was, trying to lie and sneak past somebody else. So, and I have seen the cameras of the rock cut, but I have never seen one where it's public. But it would be an awesome time lapse, wouldn't it? Like 24 hours of the rock cut and like the boats just flying through.
Mm-hmm.
I see someone's commenting the cozy corners right by the entrance to the rock cut. That is one of the good places to watch boats, to see them in and at the rock cut. You can also get something to eat. I was surprised. I thought someone would ask, where can you see the rock cut? Because Niebush Island is private property and most of Barbeau is private property. And the Corps of Engineers access is closed to the public because, of course, it's not safe. And there's two places to watch. That's the Niebush Island Ferry or the Cozy Corners. And then if you want to go to the lower end of the rock cut, just past the cut, pretty much where Scenic Drive ends, there is a boat launch there, a Michigan DNR boat launch, and that's another really good place to watch freighters.
Okay. On a typical day, how many ships pass through the rock cut?
That it all depends. It could be one that gets stuck and then no more that day. Or, if we're having a busy day at the locks for downbound traffic, it's going to be a busy day at the rock cut. And just the way traffic fluctuates at the locks, depending on what's happening at the docks and what the weather is and just where the boats are, it's going to have the same impact on the rock cut.
Okay. Is the DNR boat launch well marked? How would I find it? And isn't there also a small park with a new parking lot on the southern end of the cut as well?
That is probably about where that boat launch is.
Okay. Okay, that's all the questions that we had up until this point. We can wait a couple more minutes and see if anyone thinks of anything else. But I just want to thank everyone for attending today, and I hope you can catch our program on the 17th in 2 weeks.